we'll be talking about generic CPU architecture of 8086 16-bit processor. So let's get started with a diagram. This is the diagram of CPU architecture. As you can see, there are various registers. All of these are created by a register. Register is basically created by transistors. Now, register is formed or created using transistors. And transistors are formed using gates. We saw in the previous videos gates, and I had not explained it, but I had used the term gates. How it is, just a basic example of XOR. So transistors are formed using. Now, what do you mean by this? Is basically 16-bit architecture. So what if there is 32-bit architecture? 32-bit architecture means two 16-bit architecture. 64-bit architecture means four 16-bit architectures. So that's how the architectures are formed. Now we'll talk about registers. So this is known as, so basically there are 5 types of registers in CPU. So first is this one. This is general purpose register. So these are 16-bit registers: AX, BX, CX and DX. So you can also write it as AX, BX, CX and DX. So AX, if required, it is divided into two parts, AH and AL. AH stands high and low. So what are the full forms of these? I'll tell that now. AX, accumulator. BX, base. CX, count. And DX, data. Register. Okay, so we know these are basically used for, these are known as the workhorses of CPUs. So they come into picture most of the time for most of the requirements. So AX, this accumulator is for IO and maths. Then base register, this basically works extended addressing. What is extended addressing? Extended addressing means OS enters into the protected mode. We had seen in the first video into the real mode when it first wakes up, and then it enters into the protected mode. So when it enters into the protected mode, then this register is used for extended addressing. Next is count register. This count register is used basically for looping or recursive things. So that is the use of count registers. Data registers are used for helping accumulator register. So accumulator register, if it is heavily loaded, data register will also do the same work in helping the accumulator register. The next type of registers is segment register. This type. This is segment register. Register. So segment register has got 6 types. So there are 6 different types of segment register. First is, this is code segment, then data segment, then stack segment. Now what is code segment, data segment, and stack segment? So when a program is brought into the CPU, it is not brought at once or chunk. Only small pieces of programs are brought into the CPU, or it is sent into pieces. So when it comes into pieces, the program is divided into three things. So we have this R program is there. So it has got various things, like there are instructions in that, then there is data, I mean what are all the user data is present, and then there is variable allocation is also there. So stack is used for that purpose. So this instructions get stored into code segment. Then variable allocation or stack allocation is done into the stack segment, and rest of the things are stored into the data segment. So code segment is used for instructions, data for data, and stack for stack. So now what is ES? ES stands for extra segment. Okay, extra segment is used to help code segment. And now FS and GS. So there are no full forms for FS and GS. It is just the alphabetical continuation of the previous code segments, previous segment registers, alphabetical continuation. So there are no full forms for this. Okay. Now next type of registers. Yeah. So there are three types of pointer register. These two are pointer register. No, not these. These two are pointer register. And this is also pointer register. SP stands for stack pointer. BP stands for base pointer. And IP stands for instruction pointer. Works in conjunction with the stack segment. So it points to all the stacks that are present in the stack segment. And base pointer works in conjunction with the data segment. Base pointer works in conjunction with the data segment, and base pointer points to the parameters of the functions basically. Then comes the instruction pointer. Instruction pointer works in conjunction with the code segment. So SP stack pointer for stack segment, base pointer for data segment, and instruction pointer for code segment. Next type of register is index register. There are two types of index registers. First is source index, and second is destination index. Okay. These two index registers are basically used for string manipulation. For example, so we are having different languages in the world, right? So we are using some of the strings will go from left to right, and the other maybe Urdu or some other language will come from right to left. So it will point from source index to destination and then from right to left. So it's kind of a pointer to both the strings, basically used for string manipulation. Next type of register is flag register. So there is only single flag register. You can see here. It is a 16-bit register. Flags register is a 16-bit register which is used for giving the status of CPU. So there are various flags present in the flags register. Maybe I will maybe we can go through the flags register some other time, and just understand that flags register is for status symbol of the CPU. There are two parts, as you can see here. I have divided it with dotted line. So this part is known as EU. EU stands for execution unit. Then there is BIU. BIU stands for bus interface unit. And then there is bus control unit. This, you can see bus, right? This bus brings the programs in the segmented format in the CPU. So the segmented programs are brought into CS, DS and SS. Code segment, data segment and stack segment. From code segment, instructions are sent to instruction control unit. It is in the FIFO format. So first instruction and then second instruction, all these instructions are stored into the this instruction control unit. So one by one these instructions are sent to instruction pointer. So it is sent to instruction pointer. After instruction pointer it goes to ALU. So ALU is basically brain of CPU. So it's a brain of brain. So ALU does all reasoning and maths and everything. So decision making is done in ALU. So after ALU has done its processing, it goes to control unit. This is control unit. This is arithmetical and logical unit. And this is control unit. So after ALU, it goes to control unit. So control unit decides where this calculated data needs to be sent. It has to be sent to general purpose register, or it has to be sent to these pointer registers, or it has to be sent to index registers. So in this way it decides which register will work on the data, and after processing the data it sends the result through bus. This bus is called as internal data bus. So CPU sends the result to internal database, which it sends to bus control unit, and from bus control unit to memory control unit, and from memory control unit to finally to RAM, where we get the result. So this is how it is a basic 8086 CPU architecture. So only one thing I would like to explain in the next video, maybe flags register. That is an important topic. So we have covered a basic 8086 CPU architecture, 16-bit architecture. It is a generic diagram. If any CPU is there, it is extended with the same architecture.